Thanks, y'all, for coming. This is amazing, and tons of people here. This is probably one of the most comfortable I've been giving a talk. It's from home and super nice. I didn't have to go anywhere. And I'll be monitoring the chat and the questions that are coming in here. So please free to ask things here. If some people are saying they're getting an echo. Hopefully, is that everyone or someone? Well, spam things in chat if you have problems or questions, and I'll hopefully see it. So today I'm going to talk about an overview of Substrate as a framework. So what do we actually mean with this? And so I'll get into some of the opinions or non-opinions that actually make up Substrate as well. So first of all, let's start by talking a little bit about what a framework even is. I think it's useful to start off with some definitions here. So I think the most traditional sort of classic way of defining a framework is this inversion of control principle. By this definition, it sort of goes that your code, the code that you've written, if that is calling something else, then that something else is a library. And if something else is calling your code, then that something else is a framework. So this is this inversion of control principle. And by this definition, Substrate is obviously undoubtedly a framework. It's a bunch of code where you slot in your runtime, and Substrate calls that runtime for a small piece of its logic, e.g. how to move from one block to the next. But I think more colloquially, people tend to talk about frameworks more in these terms, or which, if not invented by, then at least popularized by Ruby on Rails, and it's this notion of convention over configuration. So there are groups of libraries, like if we talk about the JavaScript world, there's this mean stack, for instance, and people tend to refer to that as a framework, even though maybe by the inversion of control principle, it's not actually true. But they like to call it that because it's a collection of libraries with best practices and standards and sort of conventions that people ought to follow to use this thing. And when you're using it, it feels like a framework. And the reason I bring up these two definitions is because I think both of these definitions exist in the world of Substrate. And I think it's useful to sort of proceed with these in the back of our minds. We've gotten some questions already. So if we take a look at the anatomy of a Substrate blockchain, this is roughly what it looks like, right? There is a runtime that you define, that's your application. It runs on top of or inside of Substrate. And then Substrate takes care of things like hardware abstraction, talking to the internet and the real world. And it's really a very simple model, but there's something that looks extremely similar to this. If you're building a traditional Web 2.0 application, you're probably deploying it on Apache or Nginx or some web server like it. So if you wanted to build a new web app today and you started by rebuilding Apache, people would think that you're crazy. Like, you just don't do that. But this happens all the time in the blockchain industry. And this is, in some sense, the problem that we're trying to solve. But this poses a sort of fundamental question. If Substrate is a framework, does that mean that Apache is a framework, for instance? Well, technically, according to the inversion of control principle, it should be, right? But people don't really call it that. You don't build your web app for the Apache framework or in the Apache framework. You just don't think about it like that. We've moved beyond thinking about it like that. And that's to some degree what we want to have happen with Substrate, right? So this leads me to the biggest opinion that we hold and why we've decided to build Substrate in the first place. Developers should not have to reinvent the wheel of basic blockchain building blocks every time that they want to build an application. Basically, you shouldn't have to build a blockchain client just to build a blockchain. Substrate, in some sense, should be the boring thing, the obvious choice that just gives you what you want, because all the exciting bits are in your application, in the blockchain runtime. We shouldn't really think about Substrate as a framework. We should think about it as the underlying engine that's doing the heavy lifting so that you can focus on your application. I hopefully did say Nginx, but I don't know what I said, but I did mean Nginx. But let's talk about Substrate as a framework, just for the sake of the rest of the talk. Something that is asked a lot about frameworks is whether or not this framework is opinionated. Rails is an example of a very opinionated framework. For instance, if you share those opinions, then things are really easy to do. And if you don't share those opinions, then it's really hard to do, but not impossible. So what about Substrate? Is it opinionated? Well, yes, to some degree. We have a set of basic opinions that have brought us to this point and why we built it in the first place. But our strongest opinion is also that it has to be generic. So in a sense, an opinion we have is to not have opinions. But let's dig in a bit and examine what some of those basic opinions are. So at the very core, the very fundamental opinion that we have is that blockchains need to be able to be upgradable. Upgradability is a core feature that we must have. And we've seen this go wrong in so many places before, where upgradability was not a thing. And this is actually a relatively controversial opinion, right? If you talk to some Bitcoin people, they would probably say that things should never upgrade. It should just be this static thing forever. But we believe that to be able to iterate and to be able to move on, we have to have upgradability. And another opinion that sort of falls out of that is WebAssembly. So WebAssembly is a relatively strong opinion that we have, that it's a relatively strong bet that we've made, and using that as the hardware abstraction. Because we want upgradability, we want to be able to have something that expresses computation in a generic way, and that can then be put on chain and upgraded that way. But we could have made other choices here. We could have said, we're going to do x86 assembly, and that would have worked too, but only on a subset of machines. In some sense, WebAssembly is also a bet on future-proofing. WebAssembly interpreter is relatively easy to write. Compilers exist and are decent. And in some sense, even if x86 doesn't exist in 20 years anymore, we believe that we can compile WebAssembly to whatever hardware actually exists at that time. The other bet is on libp2p and using that as our networking layer. Now, libp2p is itself an incredibly generic thing, and you can add and remove a bunch of things to it, but at the fundamental sort of a handshake level, that is what it is, and it's not really easily replaceable in Substrate. But this is sort of an opinion that we should go with something generic, something as standard as possible, and not build our own custom stuff everywhere. Another huge bet is on like lines. So we've seen, for instance, in the Ethereum world, there exist only a couple thousand nodes, but something like Infura is getting billions of requests every month. So in essence, like by number of users, Ethereum is centralized. But there's a whole discussion to be had around this, around gateways and what purpose they serve, and onboarding ramps and everything else. I think there's a necessity to some aspect of this kind of thing. But to solve the problem for real, to have proper decentralized infrastructure, like clients are at the core of that, and it's something we really need to pay attention to. And so that's a relatively strong opinion that whatever we build into Substrate has to be like client friendly. Rust is obviously an opinion, but to my previous point, you shouldn't really have to care. If you're just writing a runtime, you really shouldn't have to care what Substrate itself is written in. Something you should have to care about, though, is the API between Substrate and the runtime. Things like encoding, host functions that we expose, many more things at this API layer. And here we have some somewhat strong opinions that are informed by our past experiences. So, as an example, precompiles is an often talked about thing in the Ethereum world, and it causes so much controversy and so much discussion, so much needless overhead, both technical debt and political debt, to actually talk about these things. So we don't really want to go down the route of having one host function for each crypto signature that you may want. Instead, we try to go generic, and we try to say, okay, well, what if we expose a big num library as a host function, and then maybe writing all the crypto stuff inside of WASM inside your runtime is actually good enough. Off-chain interactions is another huge field and sort of topic of opinion that we have. Many people would say, and it's actually somewhat controversial as well, like many people would say that blockchain lives in its own ecosystem. It only exists for its own sake, that it shouldn't talk to the outside world or the internet or other blockchains. But we're saying, no, like to actually deliver the Web3 vision, blockchains need to be able to interact with the real world. And so our off-chain framework, our off-chain workers exist for this. Off-chain interaction is super important. And we do have some convention over configuration in Substrate as well, but we're saying that it should be extensible. And this is actually a huge thing. Extensibility is key. If Substrate is the Apache of the blockchain world, then there's one thing that we should have to expect from Substrate, and that's to be able to meet the needs of developers. And the way to do that is extensibility. Even though it's a framework and we have certain opinions on how things should work, there are many things that we couldn't or shouldn't or even couldn't have opinions on. Talking about conventions, we set the convention of having proof of stake. But if someone really needs or wants proof of work, there shouldn't really be anything stopping them. Consensus algorithms in particular is an area that I believe should be utterly boring. Like cryptography should be boring. If you're using cutting edge crypto that hasn't stood the test of time, you're probably doing something wrong. Consensus algorithms, I believe, should eventually get to that same point. That said, we're not there yet. Us and many others are still innovating on this front. Because real world demand necessitates innovation. And so we can't expect that whatever exists today is what will exist in 10 years. So consensus needs to be swappable, extensible. Same goes for databases. Innovation, engineering breakthroughs happen here all the time, including from us. There are simply too many uncertainties in this industry today that we can say, here's the perfect framework for building anything that you might need. So genericness, abstractable, these are key values that we have in Substrate. Maybe someday there might even be easy plugins or whatever with Substrate. I mean, the Apache website, as an example, again, lists over 130 modules, and I'm sure there are many more out there. And I don't think that Apache would be where it is today if these modules didn't exist and if extensibility wasn't a factor. So we can't have a talk, especially not an online talk, without the obligatory meme, right? So what I'm talking about here is, of course, Frame. The way we at Parity write runtimes, and it's currently the easiest way to write a runtime. So Frame, is a framework within the framework. I talked about those two definitions earlier, and this one very strongly follows the convention over configuration path. What I should say, though, is that it's completely optional, right? You don't have to use Frame. You can write a runtime in whatever you want that compiles to WebAssembly. It doesn't have to be modularized. It doesn't have to be anything. But Frame is what we use. Frame is what we build for ourselves to build Polkadot. And it's relatively opinionated on how to best build a runtime and like what you should care about, all these things. And I'll get into some examples. It's definitely more opinionated than Substrate is. In many ways, this is us saying we believe you should be writing runtimes like this. Whereas with Substrate, we're saying we want to provide the tools for you to build whatever you want. And specifically, you have to care about Rust now because there's no other way to use Frame than to write Rust. And we have lots of convention over configuration. I'll get back to that. Some people do say, though, that it's not really a framework, it's a set of libraries. And, depending on how strict you are in the definitions, that can ring true. So there's a large set of libraries and existing palettes to pull from or directly use. So these palettes, the fundamental unit of Frame, should be composable, and you should be able to pull them together with your own and with ones that we've written. So some examples of opinions here are, for instance, that we use Rust, as I said, but it actually goes a bit further than just Rust. We're actually imposing quite a few other things. So it's no stud environment. For several reasons, actually. A common belief is that it's just to be able to compile to WASM, but compiling to being no stud is not a guarantee to compile to WASM, and you can compile some stud code to WASM as well. So they're not mutually exclusive in that way. But being a no stud environment sort of removes a lot of foot guns. Someone asked what a foot gun is, and it's basically just the ability for you to easily make mistakes. We try to remove ways that people can shoot themselves, and remove ways of easy mistakes. And the macro DSL is actually a hotly debated topic. Many people hate it. Many people love it. Many people hate it. Then, expand the macros and see what it looks like without the macros, and then they love it. But it's sort of the core, thing is making it as boilerplate free as possible. But it goes back to that previous point too, trying to remove foot guns, trying to introduce conventions, trying to make things easily auditable, things like that. So another thing is metadata. All palettes have associated metadata, and it's actually a really powerful feature. It makes it possible to figure out what a runtime exposes, but it's also very opinionated. There's been 11 versions already, so you can tell that there's a lot of opinions on this. The weight system, while not necessarily being particularly controversial, is an opinion that we hold on how you should calculate and set your fees. Kev will speak more later on this today, so hopefully we'll get deeper into this. So what really is Substrate then, and what are we doing? Well, our mission at Parity is to build Web3. So what does that mean? The clearest expression that I can think of is actually Substrate itself. We're not trying to make the simplest blockchain framework that can spawn Bitcoin clones left and right. We're not trying to add every single feature that may be desirable for anyone to build any sort of blockchain. We're trying to build a framework for what we believe is necessary for Web3. So what do we actually believe is necessary? Well, there's a bunch of learnings that we've had through building Ethereum, including clients for all of the sort of derivative networks of that with various consensus algorithms, etc. For Bitcoin, for Zcash. Not only have we learned many technical lessons there on how to avoid technical debt, how to write code so that it works well, but there's also a lot of social political lessons in there. Like I mentioned earlier, upgradability is one of the key ones in there. But what will be necessary for a Web3 world? Well, it's really hard to say. I don't think anyone really has the perfect answer for this right now. Polkadot forms a sort of core thesis of what we believe is needed. And there's plenty more to read online about that if you want to. But we've also been working with all of the builders in this Substrate ecosystem over the past 2 years, and this has expanded the view as well. So an example is right now we're looking at how can we make trusted execution environments easier to integrate, easier to deal with from Substrate. Um, we saw out there that some people are trying to do things with TEs. So we sort of brought this back and thought, okay, well, what tooling can we provide to make that as easy as possible? Um, Another thing is the off-chain workers. This is sort of a fundamental belief of ours, but it's also something that we've heard a lot of feedback on. There should be libraries to make this or that thing easier, and um, we try to listen as much as possible and bring that into this as well. So in the end, I kind of believe that you shouldn't really think of Substrate as a framework. You should barely even think about it, to be honest. It should just be there. Substrate should be just the obvious choice for anyone building Web3 technology. And Frame is the thing that you actively work in. Frame is the framework that you actually learn, that you will use to build all the great future Web3 applications. So yeah, that's our sort of fundamental belief as Substrate should just exist. It should just be there at the base like a web server is. And it should give you what you want. So that's it for me. I've already seen some questions in chat, and I have some questions here in Crowdcast, so I'll try to address those. Someone was commenting about the lack of tooling around Rust macros. I think that's true. That's something that we suffer as well. I think the upshot of that is that we're working actively with the Rust community. We have some people inside Parity even who's trying to improve that tooling, and it feels like it's right around the corner. Our own docs are sort of incomplete on this as well, which I sort of agree with, but we're working hard to improve. Okay, let's turn to the questions. What's the fundamental difference between Substrate and Cosmos? There's many answers to this. Obviously, one could compare features. I don't think that's super useful, but there's a philosophical difference too, right? Where with Substrates, you're buying into less, I would say. It's more generic. It's more, what do you need to build a Web3 application? Whereas Cosmos SDK is, how do I build a Cosmos chain? In many ways, if we're just comparing them as frameworks, it's kind of like they have very different philosophical goals, and you could compare features all day and whatever. But I think once you also bring it into the larger view, right, of what can I do with Substrate and what can I do with a Cosmos chain, if you're just trying to build sort of basic private blockchain, maybe it doesn't matter all that much. If you're trying to build a real public decentralized blockchain, then Cosmos actually doesn't give you any tools to do that. And Substrate, if you build a Substrate chain, you can connect it to Polkadot and get all of that. So it's sort of comparing apples to oranges if you look at the larger ecosystem, which is why it's a very hard comparison for me to make. Like the comparison usually just devolves into comparison of features, but to me that's not really the interesting point. Is there an understanding or roadmap how DeFi will develop in Polkadot? No. There are many people who are attempting with Substrate, and I think many of them are actually here today. I'd be super curious to hear what they think, and maybe in Discord later. But Um, my personal belief is that there will probably be one main parachain for many things, and then once some particular thing is starting to scale and grow and prove itself, it might become its own parachain. But I don't think it's particularly efficient to have everything its own parachain from day one. How do I bake bread? My coronavirus hobby has become baking bread, which is why someone's asking. But it's sourdough bread, so it's a long process to explain. Question about upgrades. Let's say we have two modules, A and B. B depends on A. Is it possible to upgrade just module A? What would happen to module B? It's not possible to just update one module in an upgrade. An upgrade is holistic. Your runtime is holistic. It's one blob. So you would basically have to make A work well with B before you can do the upgrade. What level of proficiency with Rust should you attain to be productive using Substrate? I think this is a great question because this is something that everyone struggles with. Um, And my answer is almost none at all. Just start doing it, start using it. You have to learn a lot of, like, if you're using Frame, you have to learn a lot of Frame stuff anyway. And you might as well learn Rust on your way of learning Frame. So that's how most people get into Ruby, right? They start using Rails and they learn Ruby on the way. I think you could do the same thing here. Why Rust instead of Haskell? Well, Rust is performance. I think that's the main thing. Some people asking about what machine you need to run to have to run Substrate. I think that's generally like, what machine do you need to compile Rust? It's hard to compile Rust. You need many cores, but you could do it on anything. It just depends on how long you're willing to wait for it compiles. I think I'm actually at time, so I'm gonna take a lot of these questions to Discord, and cut off here.